Okay, LeetCode problem 199, binary tree right side view. Given the root of a binary tree, imagine yourself standing on the right side of it and return the values of the nodes you can see ordered from top to bottom. So if we're standing on the right side and only the nodes we can see on the right side of the tree here would be 1, 3, and 4, which is what we will return. And that's the only example they give us. Also, if our tree has nothing in it, we just need to return an empty array. So I can go ahead and knock that out, our base case. So if there is no root, we can just return an empty array. And then else, obviously for most cases, we won't have that. So we can go ahead and create this queue and go ahead and initialize it with the root. And then we can create this answer array that will populate with our rightmost values. And to do this, we'll use breadth first search, which will traverse the tree according to each level. So the first traverse will be 1, and the next will be 2 and 3, and then the next will be 4 and 5 and 4. So it goes by nodes on each level, not by paths. So we've got that. So we'll do while queue.length. So while we have something in the queue, we can next. Okay, wait. Yeah. So while we've got something in the queue, we can check the queue's size, so the length of each level, and assign it to the level size, which is what we will use to loop through and check our final element in each of our levels to add. And then we need a next queue array, or queue, to populate with the next level's values, which would be our next queue to add, or our next, yeah. And then we can update our answer. So our answer will be, let's see, what was right now? No, it'd be answer push our, let's see, our, yeah, queue length +1 val. So our answer will be the last value in each of these queues that we're going to populate, because at the end of each of these queues, we'll have the end node on each level of the tree, which is what we're looking for, and we just push them to this answer. So then I will loop through, let I equal 0. Next, then I'll loop through each level, and let's see, yeah. Queue. Oh yeah, then node equal queue. So we'll initiate this node here, counting each node in it, and it'll be the first value in the queue. So the first node on that level. Then we need to check if there is a left node according to that node, and if there is, we can push it to the next queue. So we're just adding this array, basically this level, or each level at a time, and then we'll do the same for the right node, for the right side. And then let's see, yeah, okay, so we've got that done, and we update our answer as we go through with the last value that we pick up in this next queue. And then in doing so, we need to update the queue and also the size of our queue with whatever is in our current queue. So while we loop through, and then we can just return that should work.